Hi, my name is Mary Kate Adami.
I'm Kaylee Eccles.
I'm Ashley Hoffman.
And I'm Hallie Roberts.
And this is our oral report over the Madagascar hissing cockroach riding on different surfaces. So a little bit about the background is, according to research, riding in animals from upside down is a locomotor transition that animals have to do in order to survive. Examples would be avoiding dehydration and starvation, using senses, and reproduction. Some strategies to write include using appendages, deforming the body, jumping with stored energy. And these are some pictures we provided. MHC appendages that support writing on different surfaces include walking legs, which is the function of walking legs is movement. These help cockroaches move in the manner they do. Tarsal pads are pads that are made up of fibrous structures. These fibers flatten and move closely together to adhere to various surfaces. These are located at the bottom of the legs. This will be helpful on the smooth plexiglass surface. Tarsal claws are used to grab onto rough surfaces. They are spiked and located in the middle of the legs. This will be helpful on the rough turf surface. As you can see here is a picture of a Madagascar hissing cockroach's leg. And the tarsal claws, specifically in Madagascar, are used for climbing any surfaces or hanging upside down. These surfaces include trees, leaves, and caves. It also provides the MHC's ground support to help them move faster away or hide from their enemies.
Okay, so the objective in our experiment is to test the difference in a smooth surface and a rough surface. In this scenario, our rough surface is a piece of turf and our smooth surface is a piece of plexiglass. There's a significant difference in these two surfaces. So the turf's rough surface allows the MHC to grip on to write faster, and the smooth plexiglass could be more slippery and not as easy for the MHC to write on. So this is what we'll be testing in our experiment to see if the Madagascar hissing cockroach writes better on one surface or the other. Our hypothesis says this: if an adult Madagascar hissing cockroach is placed on a smooth surface and a rough surface, then it will write faster on the rough surface because it has more grip to write itself on. We chose this because Madagascar hissing cockroaches have tarsal pads and tarsal claws. These will be useful for the cockroach as they use them to grip onto each surface in order to write themselves.
So for our procedure, first you'll collect 25 random adult Madagascar hissing cockroaches from within the same colony. Each Madagascar hissing cockroach will provide 2 replications, giving us a total of 50. So you'll flip each Madagascar hissing cockroach onto their back and record the time it takes for them to write themselves. And you'll repeat this on both the turf and the plexiglass for all 25 Madagascar hissing cockroaches. And then you'll record the time of each replication in a table, find the mean of those times on both surfaces, and test the hypothesis. So Ashley's going to explain our long-term experiment table.
So we're going to look at some collective data that we went over. Mary Kay, if you wouldn't mind pressing on the long-term experiment. If you'll go back and then press on the long-term experiment. Okay, so we're going to be looking at some data that we collected as we went. You can see that the first few have names because these were the class pets that we took from the colony. We did get exactly 50 replications, so you can see just an example. Number 1, the smooth was 0.75 seconds and the rough was 0.87. And if you'll go all the way down to the table, We composed a timetable of the smooth and rough in seconds. If you'll go to the bottom, it has both of the means on there. So the mean for the smooth was 8.4876 seconds, and the mean for the rough was 2.3762 seconds. Our P was 0.045422, and our T was 1.70778. We use these for our t-test, and you can go back now. Go. Yeah. So as I
Okay.
was saying, our rough surface was 2.3762 and our smooth was 8.4876. And Hallie's going to explain a little bit of what this means.
So basically the averages of both of those show our Madagascar hissing cockroaches flipping over, and our hypothesis was proven correct because they were able to right themselves faster on the rough surface because they had a more controlled grip.
So as we said, this is our graph comparing our results. You can see here on the smooth versus the rough that the smooth average is much higher than the rough average. And this just proves our hypothesis even further that it takes more time in seconds, as you can see, for the Madagascar hissing cockroaches to right on a smooth surface than a rough surface. So this is just our graph of a visual result comparing the two.
So the significance of our results are recorded here. I want to go ahead and just explain what a t-test is for those who might be a little confused or don't know. This is from Appendix A, page 97 of our lab manual. The t-test is a statistic used to analyze data to determine whether there is a significant difference between the two means of treatment. The word significant implies a statistical difference, and use of this word is only appropriate in a scientific context when referring to such. So our t-test was one-tailed because the directionality is specified. Our t-value, as I was saying, is 1.70433. Our p-value is 0.045744, with the results significant at p less than 0.05. Our degrees of freedom were 98, and with these results, we were able to accept our hypothesis, as Hallie said, with a low p-value. This gives us more strong and conclusive evidence that supports the hypothesis. And then some specific experiment components that we thought might be useful to understand our experiment a little bit better. These were components that needed to be the same every time we did each one. And it was really important for our results that we kept these the same so they were accurate, our times were reliable, and we knew that each one was the same for each cockroach that we used. So our start and stop were really important for this. Our start did begin once we had the cockroach on its back. We held it there until we were ready to start the time, and all 6 legs had to be up in the air. They couldn't be touching fingers. They couldn't touch any surface. They had to be up in the air. And then our stop was when our bug was flipped over and had begun moving. And then another thing that was really important to our experiment was keeping it in place until we were ready. Handling the bugs could be difficult sometimes, so it was really important that we kept it in place until we were ready to start the time so we could get those accurate results. So in conclusion, our hypothesis was supported by the data we recorded, making it correct. We did not have to make any changes to our procedure or hypothesis. And then some supporting evidence we had for this was the t-test and the means of data that complemented our hypothesis. So things like this would be our data analysis sheet, our table, the means that we came up with. The graph is a good way to show you that. And with these on our side, we were able to confirm that our hypothesis was correct they did in fact right themselves faster on a rough surface as compared to a smooth surface. And here is our citations.
We hope you enjoyed our oral report.